Hello everyone! So today we are going to do an experiment that involves obtaining the equilibrium constant. So when we have our reactants, we expect them to form products, and at some point during which equilibrium has been established, then some of our products will reform the reactants and we will have that constant reestablished. So today we are using iron 3 ion, that's Fe3+, and thiocyanate ion to form a complex which will be our product of iron thiocyanate, and it will be +2. So this is a complex that will be formed here. And so there are 3 steps into this experiment that we are going to carry out. First, we will prepare the standard that will establish, that will make sure that equilibrium is far to the right, to make sure that the products are favored. So by reacting all of the thiocyanate to form our product, and we will use that to determine the equilibrium concentrations of the other species. And after we prepare the standard solution, we will also prepare the equilibrium solutions that have different concentrations of our reactants. And so that will give us different concentration of products. And finally, we will use absorbance because we don't have a direct way to measure the concentration of our species at equilibrium. We are going to relate the Beer's law by taking the absorbance reading for our species, assuming that they are on equilibrium. So let's begin by first, we have 0.02 molar thiocyanate concentration that we are going to make it to react all the way to form the product. And so I have 30 milliliters here, and I'm going to take 2 ml of this. Okay, I have 2 ml of 0.02 thiocyanate solution, and I am going to put this in a test tube that's marked standard solution, and then I will take 18 milliliters of 0.2 molar sodium ion. Sorry, not sodium, iron 3 ion. So this is 18 milliliters, and we have a very highly concentrated of the iron too. So this is going to make all of our thiocyanate to be converted to the iron thiocyanate product that we designed. So it has a color change, and this is our standard solution. Alright, so that's done. And next we will prepare our various equilibrium solutions. And I will begin by taking the concentration of iron 3, which is 0.002. So this is a bit less concentrated than the one that we used to make our standard solution. So I'll put 5 milliliters of this iron 3 ion into each of my 5 test tubes, so that I have 5 different concentrations of my solutions. And let's space out. now have 5 different test tubes labeled 1 through 5, and they all have 5 milliliters of 0.02 molar iron 3. Now I am going to add, to test tube 1, I'm going to add 1 ml of the 0.002 thiocyanate iron, and to test tube 2 I'll add 2, test tube 3 I'll add 3, test tube 4 I'll add 4, and test tube 5 I will add 5. So by the end of it, I have to make sure that all my 5 test tubes have a 10 milliliter final volume. So for the ones that I'm adding less of the thiocyanate iron, I'm going to top up with the water, fill it up to 10 ml final volume using the ionized water. So I can, so I'll start adding in the thiocyanate and topping it up with water to make sure that I have a final volume of 10 ml. Alright, so now I have all of my solutions from the standard to the 5 different concentrations of my reactants. And I will just show you that they are colored. and that you will see that they have different colors to it. Okay, so now having prepared all these different solutions with the concentrations, we are going to measure the absorbance reading. And as I measure the absorbance readings, I will have the spectrum and then have the logopro files given to you. Whenever you have your logopro file for each, it will be labeled if it's solution 1, 2, 3, 4, and 5, and the standard solution as well. Then you will scroll to where you find 460 nanometer wavelength, and that is where you will write down your absorbance value for the concentration of species at equilibrium. And finally, I'll take the temperature of one of the solutions, because that will be an important thing when we are calculating the Gibbs free energy, just for the thermodynamic section of that. And you will also have a print of one of the full spectrum that will be showing you the wavelength and the absorbance values for a wavelength range of 400 to 700 nanometers.